Section 2.2 is dealing with polynomial functions of higher degree. Basically, higher degree just means we're going to have exponents of x to the third, x to the fourth, x to the 10th, right? Just things that are higher than what you're used to seeing, which is x squared. Okay, go ahead and take a second, pause the video, write down your rules, and we'll talk about them in just a sec. Okay, if the leading coefficient is a positive number, basically what the leading coefficient means is if we have f of x equals, say, like x squared plus 2x to the third, our leading coefficient is the number or the coefficient, the term with the highest degree. We have x squared that comes first, but the x cubed is actually going to be our leading coefficient. So when our leading coefficient has an odd exponent, just like this other example does up here, what is going to happen is if it's a positive number, it's going to go down on the left, up on the right on our graph. Okay, so if we have a positive, this is like x cubed. Y equals x cubed. We know that it's going to look something like that, where it's going to go up on the right and down on the left. If it is a negative number, so if we have something like y equals negative x cubed, then it is going to do just the opposite. It's going to go up on the left, and it's going to go down on the right. Okay, if we have a leading coefficient with an even exponent, so if we have something, say, like y equals x squared, then it's going to go up in both directions. So really this is just like your parabola. So it ends up and it goes up in both directions. A negative, so something like y equals negative 2x squared, is going to have our graph going down in both directions. These are called your end behaviors. We're only looking at what the graph does at the ends. Okay, it's going up in both directions. For this one, we went up on the left, down on the right, down on the left, up on the right. These are your end behaviors. Okay, there's also something called the left hand and right hand behavior. This isn't anything different than what we just talked about, except when you're looking at your graph, what is this nonsense? You have a left hand side and you have a right hand side. So it may ask, what is the left and right hand end behavior? You're just going to say what happens on the left side, whether it falls or rises, and then you're going to say what happens in the right hand behavior, whether that falls or rises. Okay, there's only one option. It's either up or down, falling, rising, whatever you say, just as long as it's going the right direction, and I understand your terminology. I'm going to look at a few examples now. With this one, we're describing the end behavior, so whatever happens at the end of the graph. My highest term, or my leading coefficient, is negative x squared. I have an even power, so I know it's going to be somewhat related to my square root, or not my square root, what are you talking about? My quadratic. Since my leading coefficient is a negative number, don't forget, negatives, all they do is they just flip it over the x-axis. So look, in both directions, my graph is going to be going down. So you don't really have to graph this thing. It'll look something like that when you do graph it, but basically, both directions are going down, or they fall, whatever you want to say. Okay, sometimes you may also see it as they go to negative infinity. They're both going down forever, so they're going to go to negative infinity. For an example like this, my biggest term is x cubed. It is positive, so I know it's going to be similar to my cube root. Gosh, keep saying root. My cubic function. So if it's similar to my cubic function, on the left hand side it falls, on the right hand side it goes up, so on the left hand it's going to go to negative infinity. On the right hand side it's going to go to infinity. That's all you need to give me. Looking at another example, again, pick out which one is your leading coefficient first. It's the one with the highest power. This one is to the first power, this one is to the second power, and this one doesn't even have an x, so the plus x squared is my leading coefficient. Since it's squared, it's going to be somewhat similar to a parabola like our parent function. It's positive, so it's going to look just like that. So in the left-hand direction, it goes up, or it rises, or ruses. Ha! And the right hand, it also rises. So if you want to say, you can say rises in both directions, or up in both directions, or goes to infinity in both directions. Anything will work for me. I'm going to look at one more example where we are just describing the end behavior. So my highest power is cubed, so my leading coefficient is this one, similar to your cubic. However, I notice that I have a negative in front of it, so that negative is going to flip it. It's going to reflect it over the x-axis. So really, I'm going up in the left hand, down in the right hand, so the left hand goes to infinity, the right hand goes to negative infinity. Up, falls, rises, down. Okay, any one of these three things will work for me. Just make sure you pay attention on multiple choice questions, how they word it for you. The next thing I'm going to talk about is repeat zeros. Repeat zeros is when it basically just happens more than once. So if we have f of x equals x minus a, where a is some number, right? It could be 2, could be 20, whatever. And x equals a is our 0. Well, if we had x minus 2, then x equals 2 is our 0, or the point where it touches the x-axis. If k is an even power, so if we have like x minus 2 squared, see how the power on the outside is even? At 2, what our line is going to do is if it's coming down, it's going to touch it and bounce back and go the other direction. However, if it's an odd power, and I just have x minus 2, could even be cubed. This is an odd number, so it has an odd power. So at 2, what it's going to do is it's going to go hit that 0 and pass through. Notice, this one touches and bounces back. This one actually passes through the 0. Okay, there's our difference. The multiplicity of this thing is just how many times it repeats, or what power it is. Like x minus 2 squared, our multiplicity for that one is 2. X minus 2 cubed, the multiplicity here is 3. The big thing to notice about these numbers, though, is whether they're odd or even, and how they affect the graph, whether they touch it and bounce back or pass through the 0. I'm going to look at a few examples where this would actually come into play. Okay, you're going to have some that you may not have a graphing calculator to help you graph the function. So in order to graph the function, first step would be to find the zeros. Well, in this one, in order to find the zeros, I don't really want to deal with this negative here in front of the x squared term. So what I'm going to do is I'm just going to factor that out. And I have x squared minus 49. I took it out of both of those terms. So now on the inside here, this is just a difference of squares. So then I can still have the negative on the outside, and it's a difference of squares where 49 is 7 times 7. So I have x plus 7 and x minus 7. Difference of squares, so different signs on your factors. Okay, and there's our zeros. We have something times something else is supposed to equal 0 in order to have it be a 0, right? So our y has to be 0. It's crossing the x-intercept. So what I can do is I know one or both of these things have to multiply to be 0. So I just take them both and set them to 0 themselves to see when this is true. So x equals negative 7 and x equals 7. There are our zeros. Yay, I did it. Okay, now with multiplicity, it's just how many times these things happen. Since they're both being raised to the first power, they both have a multiplicity of 1. So I say I have a multiplicity of 1. Notice this is an odd, so it's actually going to pass through the zeros. Okay, there's our multiplicity. I'll get to number of terms in a minute. Let's graph this thing. Looking at your leading coefficient, right, what we've been doing earlier, we have x squared. X squared looks something like a parabola. Notice it's a negative though. So really, we want this thing to fall in both directions. Since I know I want it to fall in both directions, it has to pass through these zeros. I'm going to first mark my zeros. 1, 2, 3, 4, 5, 6, 7. And 1, 2, 3, 4, 5, 6, 7 about-ish. And it has to start somewhere down. It has to come from a fall and go up. So I have to start from a fall, go up, go up, go up, go up, go up, and pass through the other one. Okay, odd multiplicities pass through. They're both odd multiplicities, so I passed through both of them. I ended down on both sides, which is exactly what that told me. Now for a number of turns, it looks like it goes up, still going up, and then it changes direction. A turn is just where it changes direction. So since I only have one change of direction, I only have one turn. Here's another example where we're doing the same sort of things but with a different function. So to determine the zeros, this one's already kind of factored out. I have a 5x out by itself. Now all I really need to do is factor this out here. So I know I have 5x. This will factor as x minus 1 and x minus 1. Since I have something times itself, I can rewrite this as 5x times x minus 1 squared. Okay, so there's our g of x. Again, so since I have something times something, and I want it to equal 0, I can just take them both and set them 0. So 5x equals 0, and x minus 1 equals 0. So when you divide by 5, x is 0, and add your 1 to both sides, so x is 1. There are our two zeros. This 5x is being raised to the first power, so it has a multiplicity of 1. And this x minus 1 is being raised to the second power. So notice that's an even multiplicity. So it has a multiplicity of 2. It's going to happen twice, kind of. Okay, notice up here it happened twice, so we actually have 2. Our multiplicity is 2, is even. Okay, I did my zeros, I did my multiplicity. Number of turns I'll get to in a minute, and I need to graph. So I know it crosses at 0 and it crosses at 1. So it crosses at 0 and 1. There are my two zeros right here, 0 and 1. Looking at my leading coefficient, this one's a little bit tricky because I'm multiplying these two things. When I multiply them, I will have 5x cubed as my leading coefficient. Make sure you check outside the parentheses. Make sure you're not missing anything. Okay, we have x cubed, so I'm somewhat similar to my cubic function. It is positive, so it's going to look like my cubic function, where I'm going to start down and end up. So I need to start somewhere down here. I'm passing through this one because it's an odd multiplicity. Now this one at 1 is an even multiplicity, so when I get to it, I'm going to hit it, bounce off, and go the other direction. You can check with your leading coefficient test. It ended up, it started down. I started on my left-hand side is down, my right-hand side is up. So it looks like I'm good to go. I bounced off my even multiplicity. Okay, with number of turns, it goes up and then it comes back down. So there's 1, here's another. So this thing is going to have 2 turns. Another type of problem that you're going to see in this section is you will be given the zeros. You're already given the factors. It's already pulled it out of the factors and given you what the factors equal. And you're going to have to come up with the polynomial. You're going to find the original function. So each one of these things, this is like x equals 0, x equals 2, and x equals 5. Well, x equals 0, that could be like 5x equals 0 or 6x equals 0, but to try to keep it simple, I'm just going to say that x is 0. So I know that that came from an x term. X equals 2, that came from an x minus 2 factor, because in order to get that thing to 0, I had to have x minus 2. X equals 5, you had to move the 5 over, so this came from an x minus 5 factor. So when I put these things back in the equation, I have x times x minus 2 times x minus 5 equal to f of x. Okay, now it's just a matter of multiplying this out. If you want to, you can do it all at the same time. Doesn't make a difference to me. I kind of like to just deal with these two terms first and then leave the x on the outside. So if I do that, I have x and then x minus 7x plus 10, and then distribute the x to all of your terms. So I'll have f of x equals x squared minus 7x. Oh, I'm sorry, that should have been x squared because x times x is x squared. So this is x cubed, and x times minus 7x is minus 7x squared. X times 10 is plus 10x. There's your polynomial. Good to go. Hopefully this video helped you guys out understand 2.2 a little bit better. I will see you in class soon. Thank you again for watching.